Okay, let us continue examining this question. So they are Dr. Peter and Dr. John. Okay, they were wearing spectacles made of identical material and had a discussion in an air-conditioned room. So the keywords are, it was observed that the inner surfaces of Dr. Peter's lens fogged up. So you can see this part, right? Dr. Peter fogged up. Each time he spoke, but Dr. John's lens remained clear. So it is clear. So what's the difference? You can see here, this part, Dr. John, his mask was being taped across the nose bridge, this part. Okay. So when you wear a mask, sometimes you can push down, there's this flexible thing, right? But he do one extra step. He go and tape it across his nose bridge. So maybe he used a type of Scotch tape to tape it. So they say, explain why Dr. John's spectacle in this part, okay, did not fog up. Okay, so you must understand what causes this fogging. Okay, when you talk, right, because they say they were having discussion, when you talk, what happened? You release warmer water vapor from your mouth, okay, and the warmer water vapor will rise up, right, to get in contact with the cooler surface of the lens. Okay, when you tape it, this will prevent the warmer water vapor from escaping. So that's why if it can't escape, the warmer water vapor cannot get in contact with the cooler surface. Therefore, no condensation happens. So this is what the examiner is looking for. So in order to answer this well, you should say that the warmer water vapor from Dr. John's mouth could not escape from his mask as it was taped across his nose bridge. So the warmer water vapor cannot contact his lenses. Cannot contact his lenses. Therefore, no condensation happen. Thus, no fogging. No fogging. No fogged up. No fogging up. Okay, this part. Okay. Mainly, you must mention that the warmer water vapor, from his mouth could not escape. Okay, from his mouth as it was taped across. So the warmer water vapor cannot contact his lens. So no condensation happened. Thus, no fogging up. Okay. Okay, next, they move outdoor. So this is keyword, move outdoor. We have their discussion. Dr. Peter, that's been this here, okay, observed that there was less fogging on the inner surface of his spectacle compared to when he was in the air-conditioned room. So now you focus on this part, Dr. Peter. So just now was Dr. John, now is Dr. Peter. That's been he said there was less fogging. So what happened if you walk outdoor, right? you must talk about the temperature difference. Okay, so when our human body temperature is about 37 degrees. So we expect the warmer water vapor to be also that temperature. So if you walk outdoor, compared to the indoor temperature, outdoor temperature is higher, right? Correct. So naturally, the spectacle will also gain heat. Correct. So for example, let's say outdoor now is 30 degrees. Your body temperature is 37. Okay. So there's a 7 degrees temperature difference compared to maybe earlier in the air conditioned room, the temperature maybe is 24 and your body temperature is 37. So 37 minus how many? 24, right? What's the difference? 37 minus 24 is 13 degrees. It's almost double. Okay. 13 compared to 7 degrees. So this one you talk about, there's lesser temperature difference. So for this one, you mentioned about there is lesser temperature difference between, okay, between I push off between the temperature of Dr. Peter's water vapor that there's a less there's a less temperature difference between the temperature of Dr. Peter's water vapor and the temperature of the outdoors air. So there is lesser condensation. On his lenses. Okay, this one is only 1 mark, so it's shorter. So mainly you talk about there's less temperature difference between the temperature of Dr. Peter's water vapor and the temperature of the outdoor. Okay, because when he was talking, the water vapor from his breath, right, maybe it's about 37, but the outdoor temperature maybe is 30. So the lesser temperature difference. Okay, this one. Everyone okay? Okay, I proceed to the next question. So similarly, this is from RGPS 2021 prelim paper. Okay, next question also about heat loss and heat gain, also from the same school. So notice here, tower A is being rolled up, tower B is not rolled up. So it says that 5 minutes later, Tom observed that the tower from the top stack of tower B, that's in from here, was much cooler than the roll-up towers on the top stack of tower A. Okay, because initially this is hot. You take note of this, it's hot, moist tower. It's to welcome the hotel guests that come to the room. So they say it's hot. Okay, so that means this one will lose heat, right, to the surrounding air, which is air conditioned because in a hotel. Okay, but this one has more surface area, right, compared to roll up. So this question, you must use the correct keyword. So you're going to explain this observation. Okay, what is this observation? Tom observed the tower from the top stack of B. Okay, much cooler. I mean this piece here, the top stack. Okay, much cooler than one of the rolled up towers on the top stack. So you can talk about this one or either one, the top stack one. So compare top with top. Okay, because there are two layers here. This is top, bottom. Here there are 4 layers here. So for this question, you should say that the tower can use A and B on the top stack. The tower from the top stack of B has greater exposed surface area in contact. I always talk about in contact with what? In contact with the surrounding air. Surrounding air compared to the top, compared to the tower on the top stack of A. Therefore, the tower, okay, this one, the line may not be enough. So I need additional line. Therefore, tower in B, right, can lose heat faster. Can lose heat faster to the surrounding cooler air because it's an air corner. Cooler air. So this is a reason. So I repeat, you say that the tower from the top stack of B has greater exposed surface area. So what the examiner look for are these keywords here. Okay, this one has greater exposed surface area. Okay, this part. Okay, when you talk about exposed surface area, we must talk about in contact with what? So in contact with the surrounding air. Okay, compared to the tower on top stack of A. So therefore, the tower in B can lose heat faster to the surrounding cooler air. Okay, so this is 1 mark. Okay, next, to keep the hot moist tower A, to keep the hot moist tower A hot. Okay, Judy suggested storing them in a covered box before distributing to the guests. They put towers A in 2 different boxes made of metal and wood respectively. So this is metal, this is wood. So they measure the temperature after 15 minutes. Okay, so imagine you stay there in this hotel, MBS. So now they ask you from 0 to 15, right? Can you notice the starting temperature is the same, 55, right? So this one dropped lower. So this one should be metal. This one should be wood. Okay, so you key in the words. Okay, fill in the word metal. So metal should be here and wooden should be here. Okay, explain your answer. So this one thought you have to use a comparison. You must say metal what? Metal is a better conductor of heat than wood. Therefore, the hot tower can lose heat faster in the metal box. Okay. So comparison. Metal is a better conductor of heat than wood. So therefore, the hot moist tower S is it hot moist towers A. Hot moist tower in the metal box can lose heat faster to the metal surface in contact with the towers. Okay. Metal is a better conductor of heat than wood. Therefore, the hot moist towers in the metal box can lose heat faster to the metal surfaces in contact with the towers. Okay, so these are the explanation. So once again, the examiner will look for these keywords, which I highlight to you here. So firstly, this keyword, metal is a better conductor of heat than wood. Okay? If you say that metal is a good conductor, you won't get a full marks because no comparison. So there are two materials here, metal and wood. So you must mention metal is a better conductor of heat than wood. So what happened? So the hot moist tower in the metal box, right, can lose heat faster to the metal surfaces. Okay, clear? Okay, so this question is quite good. So the first 4 questions that we discussed was from RGPS prelim paper last year. So let's continue with the next questions, and I'll pause the recording here.